Hey guys, Joe up here, and welcome to the 13th video in our beginner Java series. And today we're going to be making our program. Since I just covered arrays, we're going to make a game that uses arrays, and that game is Tic-Tac-Toe. A lovely game. We're getting up there in the level of difficulty here, but follow along and it'll be easy. Alright, so let's write our pseudocode as standard, right? So how do we want to do it? Well, first off, we should start with an introduction. Right, we want to introduce everybody to the game. All right, so what happens? We'll allow the player to pick their symbol. Right, so you can choose X or O. X or O. Let's use X or O. Okay. Then we will. I think in Tic-Tac-Toe, X goes first, right? I think X goes first is like the standard rule. So we'll have so X goes first. Whether not whether whether it is the player or computer. Then right. So player's turn, we will do like ask for movement, right? Ask well, placement, I guess. We'll check for valid, like if there's already something there, you can't go there. There's already something there. We gotta make sure it's at least valid, and it is actually a number that we give them, which we're gonna label the tic-tac-toe board 1 to 9, right? And that'll, so you choose 1 for the top left and 9 for the bottom right, and they go across like a phone kind of deal, right? So, and you have to enter in a number that's valid. So we're going to do some input handling. So if they input something invalid, like a letter, we're going to actually check for that. So we're going to check if it's valid. Then we're going to check for when AI turn, and then we'll get to the AI when we get to the AI, and then we'll check when again. And then we repeat, right? That's kind of the flow of the program feeling. That's how we're gonna go. So let's start off at the top with our introduction, right? Zoom that out. Red line. Right, we're gonna say we're actually gonna make this simple, okay? We're going to make a public, put it below, because I'm gonna just make all these as public static methods. So we're gonna say public static void intro, right? And this is gonna be where my introduction is. So we're going to organize our code by making methods for our stuff. So I'm gonna say system.out.println, right? Welcome to Tic-Tac-Toe. Println. Let's make it a little fancier. Tic-Tac-Toe. I'm gonna say by Madhu. You can put your name here if you want. And then I'm gonna try and line it up visually here, but that doesn't mean it's gonna correspond in the command prompt. But hopefully that corresponds pretty well. That's my introduction. It's gonna be a very simple introduction. Alright, so we're just gonna say intro. Right, there's our introduction. So we'll start off, we'll intro, we'll go down to our intro method, we'll display this, and we'll come back. So now we gotta pick our card, our number. So what I'm gonna say, I'm not gonna make another method for this. What we're gonna do is we need a scanner object, right? I'm gonna call this input. So we're gonna create our scanner now. Equals new scanner. We're gonna say system.in because we're gonna get it from our command prompt. And then at the very bottom down here, after repeat, I'm gonna make sure I put input.close to get rid of our scanner at the very end. So we make sure that our input is properly closed when we're done with it. Okay? I'm gonna say system.out.println let's say print. Choose your symbol. I guess we'll call it. Choose your symbol. I'm gonna put X or O. Okay, we'll use capital. Alright, now what we're gonna do is I'm going to take we're gonna make a string. We're gonna say choice equals input that next line. We'll do next. Input that next. Alright, so you're gonna enter in your choice. Now, what if they enter in 2 characters? Well, that's a problem. So, well, if choice is choice dot length, because we can do that, or is it size? It might be size for string. Actually, I think it's length, because a string is an array itself. So we're gonna say that, and we'll see if the compiler complains. It might be length. I'm gonna put the parentheses there. It's because I'm pretty sure it's a method. So we're gonna do that. So we'll do something here, and then if we have it bigger. So what we want to keep actually asking for our symbol if they actually give us the wrong symbol. So we're gonna say if the length is greater than 1, or choice dot equals. Actually, we'll just do this. We'll just do if choice dot equals ignore case. So it could be uppercase or lowercase x, or so in if statements we can check 2 statements at the same time. So there's or and there's and. So the way or and works is or is one of the 2 have to be true, and both of them have to be true. So I only want one of these. Actually, we need both of these, because what I'm going to do is I'm going to actually say if it does not equal. So remember how to say does not equal? We put an exclamation point in front of our choice. So our choice that equals ignore case x. I'm going to put an exclamation point there. Say it does not equal x, and our choice that equals ignore case O. Right? So it does not equal x, and it does not equal O. Right? I'm gonna say system.out.println. We'll say invalid input. Please try again. Right? So we're gonna tell them, hey, you entered in something wrong. Let's do this again. Right? Here's another chance. Now I want this to loop until we actually get a valid choice. So what I'm gonna do here actually, I'm gonna say while this doesn't happen, while choice does not equal x or o, we're gonna keep looping. Actually, what I'm gonna do is I'm gonna take this, these 2 right here, and I'm going to move it up, and I'm gonna put it right here. Now the problem is we can't have choice inside, so I'm gonna have to declare choice outside of the while loop. I'm gonna put it above while. I'm gonna put, say, string choice equals, it'll equal to nothing. We'll set it equal to blank, which does not equal x or y. So it's going to ask for input, right? And then I'm gonna put an if statement here that's just gonna be the same thing. Right? I'm gonna copy this. Oop. Just because I want to tell them specifically if they still do not get it right. And then we're gonna have them try again. Okay, so that should work. Let's test our code before we move on, right? It's always a good idea to test your code before you move on. Oops, not run. I want to compile. Alright, we got a problem here. Equals ignore case. Oh, I misspelled ignore case. So, this is ignore, not ignore case. So we'll save, compile, and I also ignore case because I copied and pasted it. The error was twice. So I fixed that. Oops. Fix the error. Save it again. We'll compile. No problems. We run it. All right, welcome to Tic-Tac-Toe. I mean, it kind of fits. It needs one more star. So we choose our symbol. I'm going to say K. Invalid input. Please try again. Oh, 4. Okay, I want X. Right, it accepted it and the program ended because we don't have anything else. So our choice option works, right? We force the player to choose X or O. They can't choose anything else, right? Now, what we're going to do here is I need a way of keeping track whose turn it is. Like, I don't know whose turn it is. Let's keep track of that. So, it's always X's turn. So I'm going to say, let's create a boolean up here at the very top. Say boolean player's turn. I'm going to set it equal to false. By default, it's not the player's turn, right? After we do this, right, X gets to go first, right? So I'm going to say if choice dot equals ignore case. If we equal X, right, then I'm going to say player's turn equals true. So it is now, in fact, the player's turn, right? So if we choose X, it's going to be the player's turn, right? Now, I'm going to make a method specifically for the player's turn. So I'm going to make a public static void player's turn. Oh, player's turn. Actually, we have that as a name of a variable. That's not going to work out very well. I'm going to say P turn, and C turn will be computer turn. So our P turn. What do we want to do when it's our player's turn? Right? Well, we have it up here. We're going to ask our player for input. But first we need to actually show them the scoreboard, the actual playing board, so that they know what to even choose in the first place. So I'm going to make another method. I'm going to make a public static void display board. Right? And this will display our board to the player. Now we have a problem here, Houston. We don't even have a board yet. So we need to create a board. And how I'm going to make a board, I'm going to make an int array. Actually, it's going to be a char array. Yeah, let's just make it a string array because it doesn't really matter. And strings are more forgiving with input than chars. So I'm going to say a string array, and we'll call it board equals new string array. We got to have the string over here. New string array. All right, and I'm going to say this is equal to 9. So there's going to be 9 locations on our board, right? 3 by 3, that's 9. So that's our new board. It needs to be static, by the way. So I'm going to make it public static in order to be used with our static methods. Everything has to be static because of the way we're programming this. So we got our new static board. So I'm going to display the board. So I'm going to print out line, right? Board 0 plus. Now I want this to be kind of fancy, so I'm going to add like some lines in between it. Plus board 1 plus, right, make this board look fancy, plus board 2, right, copy, paste it twice, and then change the numbers accordingly. So this is board 3, 4, 5, 6, 7, 8. Okay, so that is our board displayed, but we only have the lines in between them. We don't have the horizontal lines of the tic-tac-toe board, so I'm going to add in some horizontal lines. And the way I'm going to do this is actually just by going, what's a good horizontal line? Because that's kind of flat. Let's do this. I don't know how big this has to be. So we'll just do that and hope it's big enough, and we can change it later once we see actually how big it is. There's our board. Now actually, how I'm going to initialize this board, I'm going to do it a little differently. So it's going to be a little bit more intuitive. Instead of just initializing this as a string of 9, I'm going to do that as a string of 9, but I'm going to actually tell it to say 1, 2, 3, 4, 5, 6. Oh, geez. Going all the way to the end of the page. 7, 8, 9. So now, when we display our board, if there is not actually like a letter or X or O there, it'll actually say the number. So we only have to display this board, because otherwise, if we were to display the choices, like, you know, like choose 1 through 9, right? We'd have to have 2 boards, one with the X and the O's and one with the letters, with the numbers. But by just setting it to default, say the number of the location, then we can just change that and keep the numbers. So we only have to have this one display board, right? So what I'm going to do is when it's our player turn, I'm going to display the board. Right? Let's actually go up here and say, right? So if player turn, what it should say. This player turn, so what I'm going to do is going to say P turn. Okay, we're going to call our player turn. We're going to do a repeat last. We'll put this all in a while loop. We're just going to work out the code first before we actually start putting it into our actual game loop. So we're going to do this. Now let's give this a shot. Make sure everything's working fine. Compile it. Everything compiles. Give it a run. We're going to choose X. And it displays our board. We have a little bit too many hyphens there. Let's cut down on them hyphens. I think that's as many as I wanted. I didn't actually count how many. That should work better. So now, right? Save. Do a compile and run again. Run. We choose X. We needed one less. But so you see our options here. Now we're going to tell the player to choose a location here. We're going to make sure they choose a location between 1 and 9. We don't want them to choose a 10 because it's not a location. Right? And then we're going to put an X there. And then we'll have our computer make its move. Okay? So let's do that. So I'm going to say system. .out.print. I'm going to say please choose a location on the board, right? Now in parentheses, to give them a little hint, it's going to be 1 through 9, right? We want to give them a little hint. Now what I'm going to do actually is instead of doing like int input, I'm going to say string input equals, oh no, we need our scanner. Our scanner is inside of our main, right? Our scanner cannot be accessed by our P turn because our scanner is inside the main, and you can't see variables if they're inside other methods. They have to be either out here, like our board is, where it can be seen by everything. So what we're going to do is I'm going to take my scanner and I'm going to just move it. We're going to take away this part right here, and we're going to initialize it in our main. But I'm going to declare it here. So we'll make a public static scanner input. So now our input's up here. Everything can now see our input, right? And we're going to initialize it here. Fine. So we're going to come down here to our input. Oh, we can't have these be the same thing. So I'm going to say number input. Can't have variables be the same name. So number input is equal to input.next. Right? Just the same way. Now, instead of actually doing next end, right? Because we're looking for an integer, but what if they enter in the letter D? Problem is we're trying to store it into, we'll be storing it into an integer, and D is not an integer. It'll crash the program. But as a string, it'll accept it. Okay, so as by entering it into our string, we'll be fine. So now we can actually see if it is in fact a number. Right? So what I can do here is I can now say int number input int number, I just say number, is equal to integer. This is, we're going to access the actual class of integer, right? And I'm going to say dot parse int, and then I'm going to parse our number input. Now what this is doing is it's actually going to take our string and convert it to an integer. Now the thing is if it cannot do that, it'll throw an error. Now we're going to catch this error. Because if it throws an error and we catch it, we can then tell it to say, hey, you did not enter in a number, please try again, right? We can do that. That's what we're going to do. So what I'm going to do here is I'm going to say try this code. We're going to try our code here. Now, we're going to do a catch. Now, I need to know what exception am I going to catch here. And let's go to our Java doc. So hang on 1 second. Now we're doing the integer class. So if I type into Google, if I type in Java integer, we'll get the Java doc for our integer, right? And what we're doing is we're going to parse our value. We're going to do as parse int right here, right? It takes a string input. We're going to parse our int. Now, what is the error? If it does not contain an integer, it'll throw a number format exception. So I'm going to take this number format exception, copy it, and then I'm going to, oops, not what I wanted. Do that. All right, I'm going to paste it into here. I'm going to call it E. Okay. Now the thing is because we need to also import it. I'm pretty sure we might not need to import exceptions. Let's save and see if it complains. I'm going to save and I'm going to compile. It does not complain. We do not need to actually import this exception. So exceptions don't need to be imported. So we're doing a number format exception, so it'll try and parse it. And if it doesn't work, we'll know. So it didn't work, right? We tried and we caught it. Caught the problem, right? We're going to tell them that is not a number. System.out.println invalid number entered, right? Not invalid number, but non-number entered, right? It's a non-number entered. Okay, and then we need to ask them for it again. So how I'm going to do this is I'm going to actually make a while loop, right? We're going to make a boolean up here. I'm going to say boolean, let's call it good input. And I'm going to set it equal to true. Actually, set equal to false, right? To make it make sense, right? So while good input, right? While we do not have good input, we're going to do this operation, right? We're going to ask them over and over again, right? So what we're going to do is we're going to try this code here, and if it does work, right, we're going to just continue. So we'll say good input. Oop. Right, if this code executes and does not catch, we'll say good input is equal to true. We did enter in a valid number. Here, though, I'm going to say continue. So what we'll do is we will try this code. If it is not a valid number, we will continue. Right, so we will ask them again. All right, and actually, let's and now we can keep actually doing this here. So instead of doing, yeah, we'll just leave it like that. That works out well. Now what I'm also going to do, so we got a valid number. Now I don't want to declare this in the try, because if it's declared in the try, I won't be able to say number out here. It won't actually, it's not able to see it because it's inside of our try. So what I need to do is actually move the number out. So we say int number equals null. I'm going to set it equal to null. Then I'm going to get rid of that, right? Like our null is equal to nothing. It's not actually initialized. So I'm going to set my number equal here. And then if number is equal, all right, we have our actual number that we input in. We have a valid number. We know it's valid because we checked. It is a number, right? If number is less than 1 or our number is greater than 9, it's not within range. So what I'm going to do is I'm going to say system.out, scroll down a little bit, that println number not between 0 and 1 and right, and then we're going to continue. So what's going to happen is we're going to ask them for another. We're going to ask them again. Right, we're jumping back up to our while loop top, and we're going to ask them to choose again. Right. So we've gone through 2 checks now. We've checked to see, did they enter a number? Yes. Is the number actually on the board? Yes. Now we need to check if the number location they chose is a valid location, right? Can we actually make that movement? Is that movement legal? Okay. So I'm going to say if, right? Board number, right? So they gave us our location. We're going to choose number. Now the thing is I told them 1 through 9. But our actual board array goes from 0 to 8. So I'm going to -1 from this. If our board dot equals, right? Ignore case, just to make sure whether or not it's capital or lowercase. It should be capital, but we're just going to say ignore case, because I don't care if it's capital or lowercase. If it equals x, or our board location at number -1, that equals ignore case. Oh, we looped around. Our line's getting pretty long here. Equals 0 or O. Right? If our location that we chose equals any of these, can't actually have it wrap here. Let's go to word wrap. Turn that off. I don't want it to word wrap. So, right, we got our thing going on here. So if our location that we entered is not valid, right? There's already something there. I wanted to say system.out.println spot already taken. Right? And then I'm also going to continue because I want to ask them again. You chose a bad location. Choose one that is a valid location. Right? Now, if they have passed all 3 of these tests, they entered a number, the number is between 1 and 9, and the location is not already taken, we can now officially say board location at our number -1 equal to our player's symbol. But the thing is we don't actually know what the player symbol is because we only know it's their turn and our P turn. So we actually have to store which they chose. So what I'm going to do is I'm going to go up here to our public static area. I'm going to say public static string player symbol. Right? So what I'm going to do is come down here. And then I'm going to say player symbol is equal to choice, right? So where we chose, right, our choice, I'm going to set our player symbol equal to that, right? And I'm going to make sure that it's uppercase. I'm going to say to uppercase. This is a method inside of our string, which will set the X or O to uppercase. Whether it is or it's not, we want it to be uppercase. So we're going to set our player symbol to an uppercase, whatever they entered. I'm going to say number -1 is equal to player choice. Okay? And that is our player turn. I'm going to save, and we're going to compile. And we're going to see if we have any errors. We have an error. Number equal null, incompatible type, null cannot be converted into. What we're going to do here is actually thought about that. Where's it at? Oh geez, throw it away. Number equal null, just say 0. Because 0 is an invalid input either way. So we're going to save. We're going to compile again. What was the other error? Player choice. Error cannot find symbol player choice. What did I call it up here? Player symbol. We don't want it to be player choice, we want it to be player symbol. That's the mistake here. I mistyped. So this should be player symbol. Save. Compile. Compile's fine. We'll run. We'll choose our symbol. We'll say X. Please choose the location. I want location F. Non-number entered, right? That's not a number. I want location 10. That number is not between 0 and 9. Let's choose 0. Number not between 0 and 9. Okay. I want to choose 5. That is a valid location. Now, we don't see our board, but that should have changed this location on our board right here, this 5, to an X. All right. We now have our player's turn done. Whoop whoop. We're getting there. We're getting there. All right. This is going to be a long video. Right? We're almost there. So we got our player turn, right? So this is if it's our P turn, right? So I want this to be an if statement, right? If player's turn, do this. Else it's our computer turn. Our computer turn. Which I'm going to call it C turn. Okay. We already asked for this. Check for valid. That's going on inside of our actual turn. Check for win and AI turn. We got this right here as our AI turn. And we don't need a check for win. So then we'll have a check for win, and then we'll just repeat this loop here of seeing whose turn it is, and then we'll change turn. Oh yeah, that's a good idea. Actually, down here is after we've completed our turn, I'm going to hop down here. I'm going to say player's turn equals false. It's no longer our turn. Okay. So what I'm going to do now is we're going to have a C turn. So I'm going to make a public static void C turn. Add a semicolon. Alrighty. Now we got our computer turn. Now how are we going to program our computer? Now we can make this as advanced or as simple as we want. Right? And it just depends on how long we want to spend making our. So what I'm going to do is I'm going to have it choose a random location on the board and see if it's a valid location and then place it there. That is actually step 1. And then step 2 would be the C, to have the computer intentionally block movements by the player. But I think that's going to be a follow-up video because that'll take a little bit more time. And this video is already 32 minutes. So let's just do that. So I'm going to say int location, right, is equal to our math.random. Remember our math.random? Our math.random chooses a number between 0 and 1, but never 1. So it's all the decimals between 0 and 1, right? I want to multiply this by 9 because we have 9 locations. So this will give us an input, right, between 0 and 8. But we also have our decimals there. We want an integer, so I need to change this to an integer. This now gives us the location between 0 and 8. Actually, we'll just leave it like that because there's no reason to do it the same as the player. We're not doing 1 through 9 and then having to subtract it. There's no reason to do that. Now, what I want to do is boolean valid location equals false. Let's say, yeah, we'll just do false. So while not a valid location, right? What I'm going to do is I'm going to say, so if, right, I'm going to go up here. I'm going to take this if statement just right out of here because it's the same thing. It's our if our order. But instead of number -1, I want locations. Copy, paste, copy, and paste. So, oops, not all that. So if our board already has a location there, right? We'll just say if it's not, right? We're going to check if it's a valid location. So if it does not equal X and it does not equal O, then nobody has a location there. So what I'm going to do is then say board right at location. Now we got to set it equal to the computer symbol, right? So if we chose X, then we want to set it to Y. O. If we chose O, then we want to set it to X. Okay? Now, here's the problem. We don't know. Now, I'm going to use an if statement that I showed in the if statement video that is one line to solve this problem. So what I'm going to do is I'm going to say player symbol dot equals ignore case, right? I'm going to see if we're X. Question mark. Does player symbol equal X? If it does, return O. Else, return X. Right? So if our player is X then we are O. But if they are not X, then we are X. Right? The computer is X. So that's what I'm going to do. And that's all you got to do for that. And we did find a valid location, so valid location equals true. I actually need to do one more thing here. This location actually needs to be in our while loop, because it'll generate a random number once and then never do it again. But we want to generate a location every time we do the while loop and check for location. And then once we're done with that, it'll exit out and we'll say player's turn equals true. And that'll move it over to our player turn. And that's our computer done. The computer is completely random at where he moves, but the computer will move. We'll make this more advanced later on. But so we now have a player turn and a computer turn, right? Let's just make it play a match real quick. So what we're gonna do is while win equals false, or how about let's say while game over equals false. Actually, there should be two equal signs. This is important. While game over equal to false. Right? We don't have a game over yet. I'm going to set a game over. Right? We're going to do this. Now, game over, I'm going to make it actually up here at the top, like all of our other ones. I'm going to make a, where's it at? Public static boolean. I'm going to call it game over. I'm going to set it equal to false. Alright, so our game is not over yet. So our game is equal to false, and we're going to do this. And then we're going to have our check for win. It's going to be inside of our loop here. Right? Our check for win will set the game equal to over to true if someone wins. Okay? There we go. Now let's just give this a whirl. Right? The game will never end. That's okay. We just want to see if we can play against the computer. Now we got a problem here. Let's fix our errors. Cannot find player's turn. Where was that at? That was on line 88. I don't have line numbers. So it's called player's turn. Oh, we have player's turn inside of here. That's a problem. We can't see it. We don't actually know it exists. So I'm going to move it out here. So public static boolean player's turn. So now it's out here. We can now use it in our other methods. Save again. We'll compile. Boom. And we'll run. Alrighty. We're going to choose a symbol. X. Choose a location. We'll choose 1. Alright. We chose our location. And now it's displaying our location. The computer moved here. Right? You see that? And we moved to 1. I'm now going to move to 5. I'm going to say 5. I moved the 5. And the player and the computer moved the 2. Now I'm going to move the 9. And I win. So I moved to 1, 2, 1, 5, and 9. The computer moved here. Right, he's a little random. He's not the brightest, but we won. We now need to actually have the game look at the board, see if we won, and then tell us we won. Right? Because right now the game is still going on. We can keep going. So I can go to 6, and then if I go to 7, the program will crash because it'll go into an infinite loop. Because there's no valid locations left, and the computer will just keep looking for a valid location, even though no valid location exists. So we're gonna get out of that because that program is done. So now we need to do a win. I'm gonna do it above our here. I'm gonna make a public static void win. Actually, I'm gonna make this a boolean. This is gonna be a function. We're gonna return whether or not we win. So how about over? We'll just determine over, and then through that we'll determine if we won or we lost. Okay? So, how can we do this? Now, there's quite a unique little way of doing this that I like, and it's going to be using int arrays. I'm going to be int array checks is equal to a new int array. So what we're going to do, right, we have our thing is like 0, 1, 2, 3, all that. You know how like our board is? Well, I'm going to do 0, 1, 2, right? That is the top row, right? And that is going to be our first check, right? And then we're going to check the next row below it. I'm going to check 3. Oop, if I can hit the thing, 3, 4, 5. 6, 7, 8. Right? So now we checked our rows. Now we need to check our columns. All right, so I'm going to say 0, 3, 6. Let's make it nice and pretty. 1, 4, 7. 2, 5, 8. All right, so that is our, we have our rows, we have our columns, and now we just need the diagonals. All right. And so what we're going to do here is we're going to say 0, 4, 8. And 6, 4, 2. And that is our array of checks. Now, how can we actually use this number array to check if we win? What I'm going to do is I'm going to say if, right? All right, now we have our board, and I'm going to say if board and checks. Let's do a for loop here, right? I'm going to make a for loop, and I equals 0. Now I is less than, how many checks do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8. So I want to do 8 iterations. So we're going to go through 8. I++. We have 8 things that we have to check. Now, I'm going to check them. If, right, if our board, right, it checks, I, oops, is that equals, right, board at checks I plus 1, right, and board at checks I plus 1 that equals board, hang on. Oop, I gotta keep my brackets here straight. That equals board at check I plus 2. Alrighty. So what is this long line of, what is this long if statement doing? Alright, so what it's gonna do is gonna take our board and it's gonna go to I. Our I will be 0 to start off with, right? So our 0 is our top left. It's going to check if it's equal to the board location checks I plus 1, which is going to be the top middle, right? So is the top left the same as the top middle, right? If this is true and the middle, top middle, is equal to the top right, right, with this, then we have at the very top 3 of the same symbols in a row, okay? Now that's just our first check. But then our next check will check this location, which is the middle. So we'll check if the middle left, middle, and middle right are the same. And then the bottom left, bottom middle, bottom right are the same. And then it'll do the columns, the left column, middle column, right column, and then left diagonal and right diagonal, right? So that'll check all the possible win locations on the board to see if anybody wins, okay? Now, if this is true, I want to return true, right? We're going to return true. The game is over, right? If we don't get this, we're going to return false, right? So if this is true and there is someone that wins, it'll, in the method here, return true. But if we get through this whole for loop and nobody has won, it'll return false. And that'll be our game is not over yet. We still have a while to go. So what I'm going to do is I'm going to say game over equals over here, and I'm going to also say game over equals over here. Okay, so we're going to check each time, right? Now if someone wins and we leave, we need to know who wins, and I want to know whose turn it is. So if the game is over, we left our while loop. If it's the player's turn, right? If the game is over on the player's turn, then the player won. Okay, so I'm gonna say system .out print line, right? Player is, I'm gonna say you are the winner. You are the winner. Boom. else we're going to say system.out.println you lost. Alright, so that is actually our game. Now let's give it a shot. Let's see if the game works. We have an error. Okay, check. That should be checks. That's multiple. So I misspelled, right? You gotta make sure everything's right. So this check should be have an S there. Very simple fix. Save. Compile it again. No errors. That's a good sign. Give this a run. Alrighty. We're gonna choose X because I like going first. I'm gonna go for the top left. Computer goes top right. I'm gonna go 5. Computer goes bottom right. I'm gonna go 9. I'm going to win. Right? I go 9. The game is still on. Let's keep going. Alrighty, we have a problem here. So what happens here is it didn't actually end. What happened? What happened? Right? I should have won right there. Right then and there. When I went 9, I should have won. It still said I won after the next movement. But what we're going to actually do here is we're going to get rid of this player's turn inside of our C turn. Right? We're not going to set it to player's turn. And we're not going to end the player's turn inside of P turn. Right? I want to actually move these into our loop here. Because this actually matters. So, right? So if our player's turn, right, and we win, right? We don't want to set to the computer's turn. Maybe we do. Actually, let's just leave it. Let's leave it there alone. Oops, I can't undo it after, there's only so many undos you can do. So actually, let's go back down here. I'm going to leave that back in. So player's turn equals false. Then we're going to go back down here to computer's turn, and we'll say player's turn equals true. Alright, so basically what I want to do, though, is the inverse of this. So it'll be the computer's turn if we win, right? We did our turn. It'll check if it's over, right? And then we want it to just leave, right? So actually what I could do here is instead of setting game over to over, I can just do this. We'll do this instead. If over, we're going to break. It's as simple as that. And I'm going to put brackets here. And I'm just going to put this all on one line. That semicolon goes with the break. So I can actually just put this if statement on one line, just like that. So if it's over, break. And same thing down here. If it's over, just break. Right? And I'm going to save. Let's give this a whirl again. Should work. File. We run. We're going to go for the same win. Hopefully the computer doesn't screw us over. 1. It went 5. So let's go 4. Alright. The computer blocked us. The computer might win this, actually. I'm going to go for 2. The computer just won. Right, but it's still not saying it wins. It waits until I do my movement. Oh, it's not even saying the computer won at this point. We have a problem here. Up, and then the game just goes on forever. We have a problem. What's the problem? Alright, we do our player's turn, and then we come back here, and then we check if it's over, and then we break. We have a problem. What is our problem? Let's look at our over code, because our over code might be the source of our problem. I'm actually going to add a star down here. Where's our over at? Over. Why does this fail? Right? So, oh, okay. Oh, I see what's wrong here. So what I actually need to do, this for loop's wrong. Okay, I had the right idea in my mind, but the problem is this goes from 0 to 8. It doesn't actually work, because when this goes to 1, this will just become here, and then it'll check here, here, and here for a win, and then it'll check here, here, and here for a win. What I actually need to do is actually say this is plus equals 3, right? And this is 8 times 3, which is 24. Alright, that's the number we want, because we want it to move down these columns. Alright, that should actually fix our problem. Let's run it, give it a go, X. I'm going to go for a top left again. I'm going to go for 5. The computer blocks me off. If the computer goes 8, it might win. I'm going to go for 4. All right, the computer went for top right. Now I'm going to go 6 and win. I win. Our win code works. The game works. We can now play Tic-Tac-Toe. We play against a really dumb computer, but we can now fully play Tic-Tac-Toe. This video has gone on for 50 minutes. Let's go for that 60-hour mark. Let's make our Tic-Tac-Toe board. Right? Or not. Now, actually, yeah, let's just make our computer code smart, right? We might as well do the whole program, right? We have it choose a random location, right? We want this to actually be our last ditch effort, because, you know, if we don't have anything to counter, there's nothing really to do. We just choose a spot at random. All right, so what we're gonna do here, right? This is if we don't have anything to counter. So I'm gonna say, now I need a way of checking if of a counter. How can we do that? Let's think about it, right? I need to check 2 squares, right? That's possibly about to win, right? Basically, check if there's going to be an over, right? We need to do a similar thing to this. So I'm going to take this checks, grab it, and we bring it down to our computer, right? We need to check to see if is the player about to win, right? If the player's about to win, stop him, okay? So how am I going to do that? I'm going to do the same thing here. We're going to do the same thing similar to our win loop. I'm going to come up here and steal this for loop. I'm going to steal all this and come back down to our computer. All right, boom. Now, what we want to do here, so we're looping through our checks, right? And we're going to check to see if they're all equal. But I don't want to just see if they're equal to each other. I want to see if they're actually equal to the player symbol. So I'm going to say, is board I equal to our checks? So board I is equal to our player symbol. Right, so we're checking them in our top left corner, right? Is it equal to player symbol? Right? I basically need to check to see which one is not equal to a player symbol. So like if this is equal to player and this one's equal to player, then I want to make my movement here. Or if this is equal to the player, this one's equal to the player, I need to make my movement here. Right? So I gotta check these, see if at least 2 of them are equal to the player, then I need to make the movement on the one that's not. So what I'm going to do is I'm going to do a loop here, and I'm going to do a for loop, right, of j into j is equal to 0, j is less than 3, j plus plus. So what I'm going to use this for is I'm going to say we're going to make it int, and I'm going to call it flags. So I'm going to set off a flag if we find one that is actually equal to the player. So if the board checks I plus j, that equals player symbol. We'll make this an if statement. Add our parentheses and add our brackets. Then I'm going to say flags plus plus. Right? We found a hit. Now, if our flags is equal to 2, right? If we find 2 locations that are in fact owned by the player symbol, we need to find the one that isn't owned by the player and go there. So I'm going to do basically another for loop, just like this one. Right? Boop. Move it up. And if the board location that we found here does not equal, right, then I'm going to say, what should we do here? We're going to do, we're going to move this valid location up, because this valid location actually helps. We can use this valid location to skip doing the random. I'm going to put it at the top of my computer. right here. I'm gonna put it up here just so I can, because I can't use it if it's below. So I'm gonna say board, right? We're gonna do the same thing right here for our placement, like that. And I'm gonna say valid location equals true. Okay. Now we found a valid location. Right? So now if we play the game, the computer, in theory, location, variable location. Location, that's not what I wanted. I want I plus j to be my location. Which is actually checks I plus j. That's the location I'm checking. File save. And now if I run it, right, and I say X, we choose 1, we choose 2. And so I chose this one, the computer instinctively blocked me off. Now if I choose 5, the computer should choose 8. Choose 5, I lost. How did I lose? No way the computer could have won right there. We have a problem here with our win. Look at that. We're discovering problems as we go. Actually, if at the end of the game, I actually want to display the board. Because that's a problem we need to fix. So, regardless of what happens, I'm going to say just display board. Alright, at the very end, when the game's over, we're going to display the board one more time. File. Run it. Give this a go again. I'm going to do the exact same thing. I'm going to choose 1, 2, 5. Didn't lose that time. It countered me. So if I go to 6, the computer should go 4, which it does. Then if I go 7, we have a problem here. Spot already taken. Huh, it skipped the player's turn. The computer's turn. The computer didn't go. So we actually need a problem. So like if it's a tie, like there's no locations left, we also need to say tie, right? So if in our over, actually, what we need to do is we check this, right? See if it's over. We also need to do the system that out. Basically, we need to do another for loop. And I'm just going to loop int I equals 0, I is less than I plus. We make a same thing here. I'm going to do int flags equals 0. Now, if the same thing right here, but actually I want to do an if, we'll just write a new if statement. We're not going to steal it from another place. So I'm going to do if board, right? If board I dot equals ignore case x or board I dot equals ignore case O, then I'm going to say flags plus plus, and then here if our flags equal to 9, then we have a tie. Okay, we're going to return true, right? So we need to know if this is actually a tie or an actual win. So we need a way of our win method actually checking to see. Here we're just saying like, oh, the game's over. You either won or you lost. So here actually we can say it's the player's turn. So actually, it's kind of a tie either way. So actually we're going to do something different than just determining if it's the player's turn, which is actually a good way to do it. But we're just going to make a, we're going to do a real quick player boolean tie equals false. And I'm just going to say that it's a tie if this is true. I'm going to say tie equals true. That is equal to tie equals true. All right, we tied. And then I can go back up to my main, right? And then when we come down here to say, hey, we won. Actually, I'm going to just put an if statement here. If not a tie, then do this. Otherwise, it's a tie. Say it's a tie. Yep. Else system that out, that print line. The match is a tie. Boom. Save that. File. Run it. Give it a check here. X. I'm gonna try and get the same kind of thing going on here. Go to 4. Right, and then if I go to 5, it goes to 6. If I go to 3, there's no way we can win. So if I go to 3, right, it did not go. We have a problem here as it actually didn't go anywhere, which is a problem. Are we not actually, we might actually have the problem of we're not actually checking to see if this is a valid location, right? Because if we do find that we can counter it here, right? Is he still going here? Is he still going there? You know, we have a problem. So actually we need to make sure it's a thing. But if we do fill up the board, it does say it's a tie. So we have a problem with our computer code here, where when we are actually checking our computer turn, or C turn, when we're actually checking to see if we can actually go here, we need to make sure that the option to go there is an option. And, right, so if it does not equal the player and the board at the location that we want to go, right, I plus j, that equals, so our player symbol, right, and I'm going to use this if statement again, right here, to determine what our computer if variable is, right, and it does not already equal us, right, if the location does not equal the player symbol, and it does not equal us, right, so it has to be an open location. I'll compile this, I'm going to run it, we're going to choose X, as always, because I just like going first. If I choose 1, he's 6. If I choose 5, he's going to counter me. I'm going to choose 2. You lost. He moved twice. See? Yeah. Okay, we have a problem here, because he moved twice. Freaking cheating computer. So, when I moved here to 2, he moved to 3 to counter me. But he also moved the 8. See that? He made 2 location movements. I lost, but he cheated at the same time. So let's we have a cheating computer here. We need to fix that. Why did he still go? Right? Oh, valid location. Valid location here is set to true. So this should not work. Oh, it did that, but it doesn't break from. Oh, we have a problem here. So basically, right? When I did my movement, there was 2 locations that it wanted to block me, right? And it blocked me at both those locations. Thing is though, if our valid location is true, I want to break out of this. So there's a break here, right? If I break here, the problem is we just break out of this for loop. Then I want to break out of this for loop. Right? Which if we break out of this for loop, that'll break us out of the whole loop. So that should prevent it from looping again. Because we'll break out of this one, right? If we find a location, which will come out of this one, and then we'll break, and this break will break us out of this one. So it should not block me at 2 movements. It can only block me at 1. Right? So we'll run it. X. We choose 1 again. Alright, he chose there. I'm gonna choose 4. He blocks me. Now I need a location where he can block me at 2 locations. I don't really have one. If I choose 5, yeah, if I choose 5, he has to block me at 6 and 9, right? So I'm going to make him choose. So he did choose. He chose 6. He didn't choose 6 and 9 and win. That was the reason that the AI won last night. So if I choose 9, I win. perfect. Our game works. Pretty sure I got all the bugs out. And only out of an hour and 5 minutes of coding. Now this is a lot of code. It is actually a pretty advanced, like an intermediate level program here. Right? This is pretty above beginner, but I feel like you guys are ready. So I'm actually going to put this code online, right? So you guys can. There's a lot here, and if you missed it during the video, I'm gonna have it so that you can see it on the side. You know, I'm gonna put it up on I forget what it's called, the website where you can just basically put notepads up. But you'll see it. It's in the description below the code. So yeah, guys. Hopefully you were able to keep along. Hopefully you learned something, and hopefully you have a working tic-tac-toe game without having to look at the source code. But the source code is there for those who need it. So yeah, guys, comment, rate, subscribe, and thanks for watching.